Welcome everybody to this IUSSP workshop on geoprocessing and spatial analysis. I am Nico van Imwegen. I am the Secretary General of the International Union for the Scientific Study of Population. And we are the World Association of Population Specialists. And if you're not a member yet, you should definitely consider to join us. You are most welcome. And remember, students can have a free membership for 4 years. I'm very happy to open this workshop as it is a first in its kind. So let me explain. In the IUSSP, we have our early career task force to boost the inputs of young colleagues in the work of IUSSP. And it has been my pleasure to work with them very intensively over the past years. It's a very active group. The task force advises the Council on very important issues like our anti-harassment policies and other issues. And we greatly value their inputs. But they do more. They also develop new activities in the context of the upcoming event, the main dish, the International Population Conference, which will convene, as you know, hopefully, from 5 till 10 December. And to whet your appetite for this conference, we have organized a series of countdown events, and you will see them on your screen shortly. Several of which are organized by the Early Career Task Force. And let me remind you, there will be more. There will also be one, for instance, on data visualization. So stay tuned for more information on these events. And of course, on the International Population Conference. And remember, registration opens the 15th of September, so make sure to join us. Enough of this advertising, so let's start with our workshop. And I'm really very happy to give the floor to the organizer and instructor, Igor Cavolini Johansson. And Igor, the floor is yours. Good luck.
Thank you very much, Nico. Good morning, good afternoon, good evening to everyone, depending on where you are. I'm going to share my screen. So my name is Igor Cavolini Johansson. I'm a postdoc fellow at the University of Campinas in Brazil. And today I'm sharing with you some additional information about geoprocessing and spatial analysis in the context of the IUSSP Early Career Task Force events. Before beginning, I would like to remind you of a few things. First, do not forget to download the Qgis, and I'm going to share with you again the link just to be sure that everyone will have it when we arrive at the moment of the workshop. I can't see the chat. Could you? Thank you. Yeah. So here it is. I will send to everyone this link. This is the most important link of the workshop. So everyone, please download the software before we begin the training session. Why do I ask it now? Because it can take some time, at least 10 minutes, to download the entire software and install it in your machine. So do it as soon as possible if you haven't done yet. Besides that, I would like also to ask you to download this folder where you can find the files. For the workshop. So the version most updated that you have there is 3.16.9 of the Qgis. So please download this one, right? Okay, and just a last reminder. please add your questions to the chat, and I will address them right as soon as possible. I will not be able to address all of them, of course, but it is important that the most relevant for you questions, add your email in front of it. So I will be able to address them afterwards. I promise in the next few days, I will go to every single question and answer all of them, the ones that are really important for you. So add your email in front of it. Okay, now we can begin. So the idea today is to pass 5 steps in this presentation. First of all, what do we mean by space? What is space? Why space matters? Second, how can space change population dynamics? And I will give you some examples in terms of morbidity and mortality, fertility, and also migration. And finally, what is geoprocessing? That is the goal of the workshop / spatial analysis. And then we begin the training session when I'm going to open the software with you, and we are going to do some bringing the data and also doing the analysis. All right, so what do we mean by space? Location where we find population groups with certain characteristics. This is important for us because people, first, they are not equally distributed throughout the surface of the world, or in a country, or in a state, or even in a city. So identifying where people live is important. But besides that, the place of residence, the study area, the working place, the community path, everything is important to understand population dynamics, and space is the basis for all of it. And something really, really special about space is, why are these people in that precise location? Why do they have that characteristics? And then we arrive to this bidirectional relationship. We have population that changes the space where it is located. And at the same time, you also have space playing a role on population dynamics. And then we reach morbidity, mortality, fertility, and also migration, right? So people change space, and also the space change population dynamics in a very simple way. This is why we are talking about space right now in the context of population studies. Okay, so does space matter? Why? Why space matters? How it matters? When it matters? We have to look at it in different ways. So here I just bring you 2 examples of the municipality where I live. This is exactly in the same city, in Campinas, in São Paulo state, Brazil. And you have the same scale here. So the size of the figures is exactly the same. So in your left, you have a community in a periphery area of Campinas, and you can notice the pattern in terms of urban infrastructure, for example, without even asking data about this community. You can see the pattern of the roads, for example. You can see the vegetation cover, how it is treated in this context. So here you can see, for example, a water body and how it is not protected with vegetation. But when you look in the other context, it is exactly the opposite. So you have bigger houses, and you have a regular path of the road, so you can guess about infrastructure in this area: water, sanitation, garbage collection, etc. Pavement also, this is really clear how it is organized. And here you also have a water body. So, but in this case, you have a vegetation protection to this water body. And you know, there are many studies dealing about the importance of vegetation, of the green areas for life quality. So just looking at two pictures in the same city, you can guess how different are the characteristics of the population from the left, from the characteristics from the population in the right, okay? In terms of life expectancy, for example, in terms of what kind of disease these people get, and comparing to the ones the other one is obliged to face, right? Because here you have most basic demands that were not still completely satisfied. So just to show you with one single example why space matters, right? And something really important is that people in the right did not got this level of life just by living here. It's not a process from the earth that gets the people and make them wealthy. This is not the process. It's actually the contrary. People that have enough resources to live in a place like this, they will have more, a better life quality compared to the ones that are not able to buy for a life quality like that, okay? And this will have consequences in terms of population characteristics and also dynamics. Okay, so some examples in terms of morbidity and mortality, depending on where you live or where you spend an amount of time of your day, work, school, etc., your chances to get sick and or to die due to specific diseases may differ. And here I bring you an example about dengue incidence in Brazil. This is a work I have conducted in my master's in the city of Caraguatatuba, that is in the coast of São Paulo state. And just to show you what we did here, these crosses are with what we called strategic points. These points are a way of characterizing places like tire repair shops or places where you can have many breeding sites for Aedes aegypti. And then we mapped all of them as you can see here, and we also created a buffer besides it in order to see if people living close to these areas were higher exposed to dengue fever. And what we discovered was that proximity was a risk factor for dengue fever, just to give you one example. And by this, we also can add other information with the same model. For example, information from the Statistical Bureau in Brazil about water, about sewage, about people that are white or non-white, relating it to the social characteristics of these communities. Then you bring an information from a geographic information system. In other words, I can bring information from the space, from the geographic distribution of these characteristics. I can bring it to for example, an Excel spreadsheet, and then do a model using information from the Statistics Bureau and also from the place where these people live, everything together. geoprocessing allows us to do this kind of process, and then we model something with statistical modeling and produce something new, something different, right? Just to give you an example about morbidity. In this case, mortality, we have a paper association between proximity to industrial chemical installations and cancer mortality in Spain. In this case, the authors found that there was an excess risk of cancer mortality in the vicinity of chemical facilities, and they distributed the type of cancer considering the type of chemical facilities that are close to these people, right? Again, you use geoprocessing to bring information to your statistical model. Fertility. So different distribution of population characteristics across space and over time can play a role on fertility and reproductive health. So here they found that areas with high fertility clusters were mostly associated with areas of low prevalence of women with secondary or higher education, low use of contraception, and high unmet needs for family planning. So these people are what we call clustered in space. What is a cluster? Is an aggregation of people in one specific area, in one specific time, with certain characteristics. Migration. So migration is space is intrinsic to this process, right? So spelling and receiving areas can have specific features that are relevant for people's choice to move in or out. So if you consider, for example, migrants from that a country facing a war, for example, and they go to a developed country, where will they be installed? If they will use their own resources, probably they will not be located in the best places of the city. So you can have clusters of these people with specific characteristics within the city. And this is relevant to understand what happens with the population in this place, right? So looking at this distribution is interesting for scientific purposes, but also for public policies development. Okay, so what is geoprocessing? It is part of a geographic information system. And this quote is important. It's really, it synthesizes what is GIS. A GIS can be defined as a computer system with the capacity to capture, store, analyze, and display geographically referenced information. In other words, it is an informatics for storing and managing data that has been identified according to location. Location is key. It is utilized in a variety of fields, including natural, social, engineering, and incorporating biophysical, biological, cultural, demographic, and economic data. This is the richness of what we are learning here in this workshop. A GIS facilitates we putting different information from different sources together and producing a new analysis. The potential of it is immense, and the idea is to explore it a little bit. So in a GIS project, the idea is to prepare the data and perform analysis. Geoprocessing operations makes able for us to select the characteristics of one area, for example, considering specific features that we are interested in, and we will see it. Something key in this process is documentation. You have to document everything that you do in order to be able afterwards to go to your data and understand what is the source of it. From where did I bring this information, and what I did in the process of this analysis. So always document everything to avoid losing time afterwards searching for the origin of one specific data that you utilized in your analysis. You may also use some geoprocessing tools in the last step of your project, specifically cartography tools, the idea of presenting, for example, study areas. Cartography is key in this process, and this is also relevant for the people who are reading your work to be able to locate where you are talking about. So we are discussing two different things here. One of them is to bring together information from different sources and conduct different analysis, producing something new based on this merging of information. And there's also this other part that is representing the data, representing the area where you are working, for people to be able to find it in space easily. You're going to see that. So spatial data, you have raster images that are composed by pixels. For example, you have satellite images, you have aerial photos. So you have a picture and you have pixels. Pixels are that small squares. Each small square is a unit of information in the case of a raster image. But you also have vector data. What is vector data? It has some features. For example, it can be points, lines, and polygons, as we will see. And it also has attributes. It also has attributes, for example, size, type, length, etc. So when you see a map, you will also be able to have information based on each one of these locations. And we will see that in the training session. So just to give you some examples of this vector data, you can have point, line, or polygon. Point, for example, it can be crimes in one specific area. You will see different points. You can see accidents in a city, for example. You can see flu cases or dengue cases, as I was saying, or COVID-19 cases, if you have access to the precise location of the patient. So you have many different possibilities. This is one way to see the vector data. The other one is line. So the line can be roads, for example, river or drains, railroad, etc. So you have one point, another point, and you have a line linking these points. This is another way to represent geographic data. And finally, you can also have polygons. You can have, for example, the polygon of one area, one city, or one country, or one continent, right? So this is different because you link, in this case, different lines, and it begins something new that is a polygon, right? With different shapes. How does a GIS work? So the idea, as I was mentioning, is the layers overlay. You put one layer besides the other. For example, if you have two layers with the same spatial unit, the polygons, for example, units of ways to differentiate areas in one single city. In these units, for each one of them, you can have population density per kilometer square. And you also can have in the same unit the tuberculosis incidence, right? And then you can conduct a logic operation, a Boolean operation that relate spatial data in different layers. And then you will be able, for example, to answer the question, what areas consist of both high population density and high tuberculosis incidence? This would select only polygons which met both conditions. Just to go back to the point of merging different information, considering the same unit of analysis and conducting an investigation, putting everything together and bringing something new out of these different sources. And here this image is representative. You have the real world, but you can have representation of this real world differently. And for example, here you have the land usage. So you have a different land usage here compared to this one in the city, compared to the farm, etc. This is a way to look into this data, a different layer. So, but you can have elevation, for example. You can have parcels. Look at here, the polygons, as I was mentioning, or you can have the streets. Remember the lines, it's a type of vector, or you can have the customers that are people living in this area, and then we have the points, right? When you look at the GIS, you'll see everything together, and you can turn on or turn off the layer depending on what you want. And you can merge the layers also depending on what you are looking for. So GIS makes possible, but it's necessary to be careful combining data. As we as demographers are really used to be really careful about the quality of data, especially when we bring together data from different sources. In the case of GIS, it's exactly the same. So we can have data from different sources, from different years, from different scales, from different qualities, right? And collected for a different purpose than yours. So maybe there is one specific data, but it was not collected specifically for what you are searching for. So they did not care much about this information. So we have to be careful when we bring this information to our analysis. And then cartography. Here, just to give you an example, you have the case of Haiti, right? And the map elements. The title here, Flood Assessment in Haiti 2010. In the blue, dark blue, you see the high flood risk, the light blue, the medium flood risk. So it's really easy to see. And sentinel sites in red. So you have the legend here, you have the data source, you have a line separating the map from the rest, you have the scale bar, you have the projection, right? The north arrow. So you have many different elements that should be considered in all maps that you produced, and I will give you some material that you can follow exactly what we expect in a professional map. Okay, so what is a spatial analysis? Tobler referenced to the first law of geography. Everything is related to everything else, but near things are more related than distant things. So again, the idea here is to bring the analysis of clusters. So you should expect to find specific diseases, for example, clustered, located together in specific places. this is the most usual thing to happen. And the idea that we conduct here is to see, okay, we see this pattern. Now we want to understand what is going on. What are the information that I can bring to the analysis that help me to understand why these specific diseases are clustering in this place? What are the characteristics of these people, of the characteristics of the place where they live? So this is the idea of spatial analysis. The idea is to bring something new, is to go beyond only the information and to conduct additional investigations. So before going moving forward, it is important to be careful. The spatial association does not necessarily imply causality. This is key of for spatial analysis. Exactly like in statistics, you can find association between different things, but it does not mean causality. For example, you can find one disease clustered in one specific place and another information that do not have any aspect related to that specific disease, but you can see it also concentrated in the same place. For example, dogs and dengue fever. You can have more dogs where you have also more dengue fever cases, but it does not mean that both things are related. So always be careful with the association that you are doing. You have to do that based on the literature, on what people already found that is relevant, that is important for studying that specific subject, okay? Always remember that spatial association does not necessarily imply causality. Okay, so what is spatial autocorrelation? Is the propensity for attribute values in neighboring areas to be similar. And here we have the information of population density in US. As you can see, population are more dense in the east and the west coast. But if we expected a randomly distributed population, the map would be really different. That would be the result, right? So things tend to cluster in space. That's the idea here. To discern clustered regions from non-clustered regions may not always be so obvious. So how can we say that, well, this is a cluster, this is more concentrated, high density areas than here, for example? How can I compare it? How can I analyze it? Visually, this is too hard. The idea of spatial analysis is to conduct an investigation to quantify the degree to which similar features cluster and where such clustering occurs. One popular test of spatial autocorrelation is Moran's eye test. And here, just to give you an example, so this is the global Moran's eye. It will say to you in one single measure, yes, there is a cluster, or no, there is not a cluster. So the idea is to look at one area, in this case, the median per capita income aggregated at the county level. And it also will look at the median per capita income in the neighboring areas, and it will graph it. So here you have the mean of that unit, and here you will have the neighboring mean, considering neighboring something that you have to choose. If you consider, for example, only the units that are linked straightly to this area, or you consider a buffer, for example, of 200 kilometers, and everything will enter as neighbor, right? And then they plot this information and look at this slope. And we then will have a p-value indicating that if you can or cannot reject the null hypothesis. The null hypothesis here is that income values are randomly distributed across each county. So if in this case it is significant, so you can reject the null hypothesis, consequently, you have a cluster of this information in space, right? So this is a big picture, a big analysis of the entire process. But you can also run the localized measure of autocorrelation, that is the Locomorin's eye. In this case, it will indicate to you exactly the areas that are one beside the other with the same characteristic. In this case, you have a area with low income besides other areas with low income, and this is statistically significant. On the other hand, you have other areas in the south that are exactly the opposite. So areas with high income per capita besides other ones exactly with the same characteristics. So if you look this one, these are the numbers, then you look here and you see exactly what are the statistically significant clusters that you can analyze, that you can investigate. Okay, just to give you an idea about one way to conduct spatial analysis. Morin's eye is very famous, and you should probably take a look at that if you have not already done so. Just before going on, remember to install QGIS and also to download the folder that I sent to you in the chat, because there we have the files for our training session. And don't forget your questions, also bring it to the chat. I will read them in a minute. So there are other measures of spatial autocorrelation, for example, Getty's ORD indexes. These are similar, but it also has different characteristics compared to Morin's eye. You have also to check it out. Are there other spatial analysis techniques? Of course, there are so many of them. It's a world of possibilities. So see variogram and kriging, geographically weighted regression, space-time analysis, etc. We are going to see especially kernel density estimation. That is the idea of transforming an information that is located in space as points, and you are going to transform it in surface in one area. Okay, it will be clear just in a few moments. Softwares for geoprocessing and spatial analysis, you have so many of them. You just have to pick the one that fits better what you need and what you can do. I mean what you can, because one really famous, probably the most famous software in the world to do geoprocessing and spatial analysis is Arcgis. This is really great, but the problem is that it is paid. So it's not free, it's not available in the internet. In my case, for example, I have access to it because my university pays for everyone in the as students or professors or postdocs. Everyone can have access to it freely because they pay for it. But the institutions that do not have it, so it's really expensive, it's hard to afford. But we have other options. And the idea of this course is to explore what QGIS can present us. And here is the link to download. You also have Geoda. Geoda allows us to do different things. It also should be explored. I will not go into details because we will not have time for that. But you also have TerraView, that is a software developed here in Brazil in our space institution research. So this is also a strong software to conduct geoprocessing and spatial analysis. And the other one that is worldwide famous is R. In R, you can do everything. You can do statistical analysis, you can clean your data, and you also can do geoprocessing and spatial analysis. The thing is that you have to understand how R works to be able to really do it yourself. So given it takes a time for people to get used to it, I chose here to show the potentialities of QGIS. That is a platform you can just click and select exactly what you want. So it's more straightforward to understand how things work. And once you understood it, doesn't matter the software in which you select to conduct your analysis, the logic will be exactly the same. Okay, so now again, please download the software, the QGIS, as I sent you the email. Select this option, 3.16.9. If you have another version, it's fine. The changes are not that big, so it will probably work exactly the same. And now I'd like to introduce you to the software itself. So here in the basis, you have the locator bar. You can type what you want of the software. In 2, you have the layers bar. This is probably the most important part of the software. Here you will see each layer as a list, and you can check on or check off each one of them, and you'll see that in a moment. In the browser bar, you can find the files that you want to bring to your analysis. You can just drag and drop from here to here, and this is simple like that. We also have the toolbars here in the top of the page, and the map canvas. The map will show exactly the layers that you have here, but projected. You see the map designed, and also the analysis that you have conducted, the result you are going to see over here. And then finally, in the 6, you have the status bar with information about your map. So now I will just take a look at the chat to see what we have here. We are advancing on time. That's great. Everyone putting the email. So can you explain the concept of Moran's I value again? Yes. So you have the global Moran's I, that is one value that indicates to you if we have or not a cluster in that specific analysis that you are conducting. In the case of the per capita income, it will say in one single figure if and with a p-value if you have or not a cluster of that information in space. This is the global Moran's eye. But you also can have the local Moran's eye. Then you will be able to look in the area and indicate exactly where are the clusters. And I mean by the cluster, the areas that are together with one specific characteristic. In this case, areas with low per capita income close to each other, and you'll see with one specific color, it will be highlighted in your map. So this is the detail that the local Moran's eye will give you that the global won't, okay? And the local will also show the opposite. In other words, the areas that are close to the others with high per capita incomes, right? Then you will be able to analyze exactly the cluster, exactly the areas that have statistically a different pattern considered to the other areas. You see this aggregation of areas in space. Okay, that's the general concept of the Moran's eye. And people asking about the link. So I'm going to share again the link for the files that we need for doing our analysis right now. And now we are going to begin the training session, okay? So again, this is the link for sharing. In this folder, it is zipped. So download it to your computer, unzip the folder, and keep it in a place that is easy to get. I really recommend that you use your desktop. That is, you know, the easiest place to find your files. Okay, so I think now we can begin the training session. First of all, open your QGIS, and this is what you will probably see without these ones that are my old maps. And here you can just click project and new. Okay, this is exactly the screen that I showed you earlier about each part of the software. Okay. Now, I will recommend you to download, actually not to download, but to look with me how we can download shapefiles. I will send you again. Actually, sorry, not again. This is a brand new link. Use this link to reach the page where you can download the shapefiles. What is this? This is the site of the IBGE, that is the Brazilian Institute of Geography and Statistics in Brazil, where we find the official shapefiles of the country, or at least a part of the shapefiles. We also have other institutions that provide shapefiles for the public, but the main one is IBGE. here I suggest you to open Município 2010, that is the municipalities for 2010. And here you have the federal units. You will find all the municipalities. Actually, municipalities are here, but you also have microregion, mesoregion, and also the federal unit itself. And then you download exactly what you want. In this case, what we want is this municipalities layer, right? So we can just click it and it will download to your computer. Let's just take a look at that. So this is what we have here downloaded. This is a shapefile. So a shapefile is the basic layer or the basic source of information that you will need in your geoprocessing and spatial analysis. From the shapefile, you can draw your maps. Why do we have 4 files and not only 1? This is because in each one of these documents, you have a different information. For example, when you bring to the map, you can just click and bring it. Actually, it was not unzipped. We have to unzip. Let's do it. Yep. Yes. You bring the SHP file to your QGIS, bring to your layer. So this is the Amazonas states and all the municipalities within that federal unit, okay? But just going back there, we also have in the same shapefile the DBF, just to show you this is like a Excel of your shapefile. This is where you find the information for each one of the units that you have there, right? As I was mentioning, a shapefile is composed by different layers of information. And when you look here, you right-click in the layer, you go to Open Attribute Table, and you see that what I called Excel, the information that you had there are here, okay? Given that I will not oblige you to download each one of the federal units, I already did it for you. So here you have 27 federal units. The idea is to open each one of them and download the municipalities from that federal unit, okay? You already have it in the folder that I shared with you. I will just delete, you right-click in the layer and remove layer. We are not going to use this one. Remove one legend entries. Yes, okay. So let's go back there and look at the folder that I shared with you. So please let me know that you are with this folder open, that you already unzipped it, and that you see exactly the 3 items that I see right here. Is it okay? Okay, okay. It's everything here. Yeah. Just click municipality for which year it's 2010, as I mentioned here. This is a question. Just remember that space changes over time. So we had the creation of new municipalities in Brazil after 2010, and given we are going to use some data from 2010, we are going to use exactly the units, the municipalities of that time. Okay, that's municipalities 2010. This is the last Brazilian population census. Okay, everyone together, that's great. So I already downloaded the data for you. Just double click. Sorry, it's not data, it's shapefiles. Shapefiles. Now, one, municipalities by federal units BR. Open it, and here you have all the federal units with the municipalities, right? The 27 of them. Just notice that I also added a README file indicating exactly the source. From where did I download this data? How did I get exactly to this data? This is Municipio 2010. And when did I download it? It's important for you to document everything. It facilitates a lot your work. Now, what we can do is just select the first until the last one. So you have 27 federal units, and you can bring the entire folder to here. It will take a time to load. Here it is, simple like that. Okay. Remember, I was telling you that we can turn on or turn off the layers according to what we want. So here, for example, I have the federal unit of Espírito Santo, that is this one. If I do not want to see it, I just turn off. Okay, and this is exactly for all the other ones. Ceará is over here. When I turn off, yes. So I have different shape files. They look together. This is Brazil. They look together because they match. They put together brings us a unique image, but actually this image is composed by different parts, and each one of these different parts is composed by different municipalities. So just to give you an idea of how many units we have here, okay? And when we right click and open attributes table, we see all the information about the municipalities. Each line is one single polygon of that image. If I select, just click and select some of them. So see here in yellow, the municipalities that I just selected in the table, they will show up here highlighted, right? You can do exactly the same. You can come here, deselect, and you can select manually. Well, I want to know the municipality in São Paulo state. I will just select it. This is São Paulo, and this is Campinas. I know that this is Campinas, but if I'm interested in seeing, well, what is this municipality? I just come here in select features, and I can select it manually. And when I come to the layer where it is, double click, open attribute table, and it should be highlighted here. Here it is, Campinas. It highlights automatically for you. Okay? Okay. Just a trick. If there is, for example, 5,000 units here and you just want to arrive exactly to the unit that you have selected, you can come to the open attribute table, come here and show selected features, and we'll show only the one that you just selected, right? To facilitate the process. So it's really simple to navigate from the map to the data or from the data to the map. When you want to bring back your map, you just come to this hand and bring it exactly where you want it, okay? To select here, to move the map here, okay? All right, so now we have many shapefiles. We want only one with all municipalities of Brazil. We want to work only in one shapefile. We can merge everything and we will do it together. So you can come to vector, just something really important. There's something that is selected here, unselect everything. Yes, we don't want anything selected because what we are going to do, we want to apply in the entire amount of shapefiles, okay? So vector, data management tools, and then merge vector layers. Okay? Please let me know if you are with me, if you are having any problems. Yes, the recording will be shared after the webinar. Don't worry about that. And also the files that I'm sharing with you. It's how to select manually. So you just come select features and you can select just clicking exactly what municipality you want to have more information. And you want, if you want more than one, just like you can just click and select all of them that are of your interest. Okay? Okay. So now we are going to transform all of these shape files in one single one. So data management tools and merge vector layers. Click in these three dots and you will see all the shape files here, right? Just select all and run. Notice what I just did. I don't know if you realized, but I changed the level of the layer. So this merged is the municipalities for the entire country, and I brought it up to the others. Then the other ones will be behind it. If I bring this behind Espírito Santo, for example, Espírito Santo will appear up it, right? So you can just click and drag exactly in the order that you want. So now we have a shapefile for Brazil. Now just select the first one of the shapefiles of the federal units and shift and until the last one, because now we can just remove this layer. Okay, oh, there is one more. Okay, now we have one single shapefile for every municipality in the entire country. We did geoprocessing. We put everything together, right? And here, the attribute table, now we have 5,567 municipalities for the entire country. Okay? Now let's move on. We have a new shapefile with all municipalities. Notice that this is a temporary layer. This symbol indicates that this is temporary. So if I close QGIS right now, nothing will be saved. I will just lose my shapefile. So it is important to save your shapefile, what you just created. Right click, then export, then save features as. This is a shapefile, it's fine. File name, clicking these three dots, go to your desktop. I would suggest you to create a new folder just to organize everything. Workshop live. Okay, and give the name for this shapefile. I would suggest BR Municipalities 2010, save. Okay, notice that you also have the coordinate reference system. You have to take a look about CRS and also about projection, because it can change the results that you will have. We will not have time to do that now together, but I just suggest you to consider looking carefully in this. But now what we need is to click in this symbol over here, and to select in the filter, you can type 3857 and select Pseudo Mercator and OK. Okay, this is just a projection, the way that your map will be showed considering the surface of the globe that is not flat. Okay, and then, okay. It will take a time because it's a lot of information. So your merged is not necessary anymore. Remove layer. Okay, now you have your shapefile saved in your computer. This is what you have just done by yourself. Okay. Notice that the shapefile is not temporary anymore. But actually, we don't want the entire municipalities for Brazil. We want only part of them. For this reason, we have to open another shapefile, that is the legal Amazon. We want only the municipalities in the legal Amazon. Come to this to and legal Amazon. Click on the shapefile SHP file and bring it to your QGIS. And here it is. This is the Brazilian legal Amazon. Legal because it is officially delimited as the Amazon in the country. Okay. Now we want to select the municipalities of that shapefile that we created based on the spatial location, only those that are under the Amazon, the legal Amazon in Brazil. Okay, how we do that? We come to vector, then research tools, and select by location. Select features from Brazilian municipalities by comparing to the features of the legal Amazon, intersect, and run. Yeah, close. So if I turn off my layer of the legal Amazon, here it is. All the municipalities that are under the legal Amazon were selected. So different layers, and I am combining them to produce something new. Let's turn it on. There is a problem here, given the drawing of the different shapefiles. So there are more municipalities here than expected, all of these ones. I will come here in the deselect. Oops, not all of them. Sorry, let's do it again. Vector, research tools, select by location, Brazil, legal Amazon, run. Close. Okay. Now you can press the Control key and click in the ones be sure that you have selected the Brazilian municipalities layer, otherwise you will not be able to deselect it. So click Control and deselect the municipalities that actually went beyond what you expected. If you not do for all of them, it's fine. I'm just showing you how you can do it. It's just to be even more precise in terms of the overlap between one area and the other. So I don't want all of these ones. Remember, I'm with the Control key, hold. Yes, let's see now. There is one here. Yes. Okay, yes. Now, I have exactly the municipalities of the Brazilian Amazon here, and I want to save them as a new shapefile. So right-click, export, save features as I told you, 3 dots, and indicate the name here, Amazon, municipalities, save. Again, it is already fine here, the coordinate reference system. Don't forget to check this option, save only selected features. You create a new file only based on the selected features. And OK. Here it is. Now you have only the municipalities of the Brazilian Amazon available to you. Now we want something different. We want to join information from a spreadsheet to your spatial data. So go to the folder data, the folder that I sent to you, data, COVID by Amazon municipalities, drag and drop here. Simple like that. Right-click, open attribute table, you will see all the information from this spreadsheet. Of course, it does not have a spatial reference, so you will not see it in the map, but the Excel file is here. Okay? So right-click in the layer Amazon municipalities, come to properties, joins, because you are going to join a file into this shapefile, click in the plus sign, join layer. Yes, Brazilian municipality, actually this is join layer, COVID, legal Amazon. Am I in the right one? No. Properties, join layer, the layer from which I want to join information. This is the Excel file that I just brought here, right? So the join field is codMum, and the target field is CD geocodem. This is exactly the same field in the shapefile and also in the Excel, and then it will bring information together. Okay, and okay. Now right-click, open attribute table, and all the information from the Excel file came to new variables here. Okay, so you just can guess the immense possibilities that you can have here. From a shapefile with one unit, you can bring whatever the information that you want, considering that you have that same code. You can bring it to the map and do your analysis. Okay, now you can do a Protoplast map, that is a colored map. You can double click. Look, this is exactly the same. You double click or right click in properties. It opens the same screen, okay? And now you come to symbology, graduated. In value, we want mortality rate per 1,000 inhabitants. Okay. You can click classify and you'll see different classes. I will choose as mode to select the categories as natural breaks. You have more information afterwards if you want. Just let me know if you want specific additional information about it. I'll be available. And in 5 classes, and okay. So now you'll see the distribution of the information that you brought from the Excel file to your shapefile. Then you begin to conduct your analysis, okay? But now, as you can see, the mortality rate per 1,000 inhabitants are higher here in the state of Tocantins and also in Mato Grosso, as you can see here, and in Rondônia. You can see a pattern of high mortality rates due to COVID in the Brazilian Amazon, in the south, and also in the east. Now we want to calculate the centroids. What are the centroids? You will bring information from a polygon, you will transform it in one point. How does it do it? It will draw lines from every single part of the polygon to the other, all of them, all of the possible lines inside each one of the polygon, and the place where more lines overlap, there you have your centroid, okay? How we do it? So you come to vector, geometry tools, centroids, Amazon municipalities. You can already save, and I will save it as centroids, Monique, legal, Amazon. Okay. And run. See here, for this entire municipality, I have one centroid. I transformed the data from polygon to point in practice. That's what happened. Okay. Each polygon now is represented as a single point. If you right-click here and open attribute table, you will see exactly the same data. The change is that it changed the labels of the variables, but the orders continue to be the same. We can change also the label here, but I will not go into this detail given the time that we do not have time enough for that. But the same information from the polygon came now to the format of points. Okay. Now we will draw a heat map. You come in the processing toolbar, you open your toolbox, and you type here heat map. Choose the first option, select Centroid Municipality by Legal Amazon, and I will give you some information to put it here. So the radius that will look besides each unit, I will use 500 kilometers. The rows, 500. And here, this is key. I will select, it's not to draw a point of where the points to draw a area where the points are more concentrated, but each point will be given a value, and this value will be the same one that we just mapped before. That is the mortality rate due to COVID, right? That was the last variable. So we select that variable to see how it is spread in space, and run. Here it is. Okay. You can just save your layer, export, save as. I will save as kernel. Okay. You don't need the other one anymore. Now you just double click and change some symbology specificities, render type. You come to single band pseudo color. Here in the color ramp, you select spectral, invert the color ramp because you go from a cold to a warm color, from low to high numbers. In min max value settings, cumulative count cut, just to be able to see easily. And okay, so here it is. The kernel indicates exactly the areas where we find points where higher mortality rates due to COVID in the Brazilian Amazon. Okay. Okay, it is already saved. Now we want, as you can see, let me take another layer. So this is the legal Amazon, and I bring the legal Amazon here. Okay, you see that it went beyond what we expected, right? It is fine. We want to crop this image exactly using the borders of the Brazilian Amazon. Okay. Now you come to another feature, that is clip raster by mask. Okay, the input layer is the kernel, the mask layer is the legal Amazon. Okay, and run. Look, it clipped only what we needed. Notice that it changed it back to the layout that we do not like. So you just come here in the kernel, you come to styles, copy style, right click in the new one, style, paste style. And here it is. Okay, the Brazilian Amazon only with the municipalities that had a higher mortality rate due to COVID-19. Look, this is a temporary file. You just have to save it, export, save as, and you indicate kernel only Amazon. Clipped. Again, it changed. So styles, paste style. Okay, that's it. We are already running out of time, but I would just like to show you the last step, that is doing your print layout, how you create an image to export and to publish, for example. So you come to project, new print layout, you give a name for this layout, Amazon COVID, for example. This is your screen, you just add your map, add map. Okay, here it is. You can also change the scale if you want to show it bigger. Okay. And you can add a north arrow. You can also add a scale, and you can also add your legend. Of course, it will show more than you want. You just go in the legend and you can just select exactly what you want. So this one is what you want. We don't need clipped. We don't need legal Amazon to show in the legend. The kernel, the centroids are not necessary, neither the Amazon, the Excel file, legal Amazon, and the Brazilian municipalities are also not necessary. So here we are. We just add a frame. Yes, now you have your map. You can just layout, export as image or PDF, go to your desktop, Amazon COVID, saving the format that you want, and save. Here it is. Then you have a file that you can bring to your paper or anything that you want, the exploratory analysis for your advisor or your colleague. And that's the way since the beginning, where you bring the shapefile until processing the data and finally producing a layout for publicizing the work that you have just done. If I have just 1 minute. Okay. Just to look at some questions that showed up here in the chat. Yes, Muna Shifa is asking, Is the name of municipalities the unique ID used to merge the Excel file with the shapefile? No, actually what we used was a code of that municipality, and that specific code in the shapefile was also available in the Excel file. And this is unique, right? Avoid using names. It's better to use numbers. And this is specific. This should be unique, right? In order to make one information from the shapefile get one information from the Excel file. Then you have a successful link, and you bring whatever the information that you want to your map and conduct your analysis. So it was a code. So people are asking, usually some problems during the process because I was too quick. I'm so sorry, but I would like to present to you the entire process since the beginning until the end. Okay. Is it possible to use a data set from Dorothy without spatial reference for spatial analysis? If not, how can we convert such data set to spatial data analysis? All right, so to conduct spatial analysis, you have to have it in space, right? So if you have a data that do not have a spatial reference in that data, do exactly what I showed here. Try to find the shapefile of that specific unit of analysis. For example, if you are dealing with countries, you have an information from the United Nations Population Bureau, and you would like to conduct a spatial analysis, but you just have the Excel file. So search for the shapefile that you bring these units, the units of the countries, to your map. Then you bring the information, the data from the Excel, and link it to the geographic information, and afterwards you are able to conduct the spatial analysis. Okay. How do we calculate global Locomorin's eye on QGIS? This is not a trivial answer to give you. When you open your QGIS, there is here, oh, I'm not sharing my screen. Sorry, let me share it again. So when you are in QGIS, you can come here to plugins, manage and install plugins. And this is exactly like R. You will download what you want. Otherwise, the software would be too heavy. So depending on what you need, on what you want, you come here and say the name of the project. Sorry, the name of the tool that you want, the name of the plugin that have that tool. It's like the library in R. You have to download it, and afterwards a bunch of new features will appear to you here in the toolbar, and then you can click and do that specific thing. Moron's eye, local and global are not available in the general QGIS. You have to download a package to do that. Given the time constraints, I did not do that because it would, take longer for the explanation. I used here the Qgis, right, the kernel, to show you something that was already installed in the QGIS, but there are many different plugins that you can explore in terms of functionalities to your project. Okay. If I have just one question more. Can we, on the contrary, from Lydia, can we, on the contrary, convert spatial data to a data set? For instance, calculate the mean number of cases per region, adding the values from heat map per municipality to then add the mean to my spreadsheet to then conduct further analysis? Yes. Don't forget that when you open the attribute table, this is a shapefile. This is an Excel file. You can download that data to your computer and use it in other softwares like SPSS, like Excel, like R. So you can produce new information using your GIS. For example, when I talked to you about dengue fever, I was searching for people that were besides strategic points. So for those that were besides these points, I added a column called strategic points, and this was dichotomic. So 0, no, or 1, yes. Okay. From this geoprocessing analysis, I brought the information to my model, and then I conducted a statistical analysis without maps. Okay, so I brought one information that I created from geoprocessing, and I added it to my model. You can do it easily. You just go there to the DB file of your shapefile, and there you find your spreadsheet. Just copy and paste and use in the format that you want according to what is necessary for your work. Okay, so we are running out of time. So thank you very much. I would just like to share my screen again for my final slides. Thank you for the questions. I will address all of them afterwards. Okay. We're back here. So some acknowledgements to Tom Legrand, Nico, Paul, Mary Ellen from the International Union for the Scientific Study of Population. Thank you very much. To my colleagues of the Early Career Task Force at IUSSP, to the São Paulo Research Foundation, that is the funding agency that supports my work about population, environment, and health. And of course, to you, the audience, during and after the workshop. The references that I presented during my presentation here are all listed. There are also additional learning references for you. Just feel free to dig more. As you can see, this is a world of possibilities. Explore it, go for it. And also a journal to follow, that is Spatial Demography, that you can learn the most developed strategies available today. Follow exactly this scientific journal. And also some free spatial data sources for you with shapefiles, with data for your analysis. And thank you very, very much. See you in the next opportunity. Nico, please.
Yes, and if I may have the last word, Igor, I want to give a big thank you to you for really an expert presentation, a great training. We have all learned a lot, and we have realized once again that space really matters. Thank you for doing so. And everybody, please remember that the link to the recorded webinar will be on the IOSSP website very soon, probably by tomorrow, so you can look over all the materials again. So thanks again. Stay tuned to the IOSSP website. We will have many more of these events. And of course, remember also registration for the International Population Conference opens on the 15th of September. Thank you to everybody. And again, thank you to Igor for a great job. Okay. Take care, everybody.